Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the practical application of Bernoulli's equation. So in our previous lecture already we have discussed the derivation of Bernoulli's equation and also we have solved some problem related to Bernoulli's equation. Now we'll see some application of Bernoulli's in the practical field. So this Bernoulli's equation, we can use this concept in incompressible fluid. First things, we can use this concept in the incompressible fluid. And apart from this, also we can use this concept for measuring devices. Okay, for measuring devices also we can use this concept of Bernoulli's equation. So the measuring devices are, suppose if you consider the flow measurement devices, so some few devices are there which will used to measure the flow, fluid flow. So what are the examples are that? One is venturimeter, and second one is orifice meter, and the next one is pitot tube. So these are the some devices which will used to measure the flow, fluid flow. Okay, and next is pitot tube. So these are the different types are there. Now first one here, what we'll discuss about the first practical application, that is venturimeter. Okay, so the venturimeter, I'll show you the diagram. Before going to this diagram and this explanation about the venturimeter, so let me tell you that this venturimeter is used to measure the rate of flow. This is used to measure the rate of flow, of fluid. Okay, rate of flow of fluid, and which is flowing some pipes or some place, so we can measure the rate of flow. Okay, and next is this venturimeter contains of few parts also there. Okay, I'll tell you the parts. So before going to this explanation of this venturimeter parts, so let me tell you some application of this venturimeter also. Okay, then we'll start that application of this venturimeter. So this venturimeter can be applied in different areas. Suppose in industry also you can use this venturimeter. So some example I'll give you, like industrial flow. Wherever some flow will be there or some kind of pipe will be there, we can use this. Okay, so that is, pipe may be there or may not be there, but there is some flow of liquid or flow of fluid will be there, we can use this venturimeter. So first one is, you can use this in the industrial flow measurement device. In the industrial flow measuring device, this is first part. And the industrial flow measuring device also I can say, like suppose chemical processing industry is there, so there also we can use this concept, chemical processing industry. Similarly I can say this can be also used, that wastewater treatment process also we can use, wastewater treatment process. Similarly many more places we can use. Now second one I'll tell you, we can use in the automotive applications. In the automotive applications. Now in the automotive applications, where you can use, where the fuel will be flows, so that will be considered as a carburetor. You can use this one in the engine carburetor. Next is, we can use this concept of this venturimeter. This venturimeter can be also used in the medical application. Now the question is here, where the medical application part is there, where you can use the venturimeter. So actually this is considered for the where there is a blood circulation is there or blood flow is there. So there you can use this venturimeter also. Okay. So the next is in many areas are there aerospace industry also, or aerospace application also, I can say. So in the aircraft also we required some kind of fuel in that. So that also can be considered in this automotive industry, and some many more applications are there in this. So basically what we are learning here, all these applications what I have shown you, here we need to find out some kind of rate of flow of fluid, some kind of fluid which should be flows in these areas. There we can identify the rate of flow. And the rate of flow already I told previously in our previous lecture what is rate of flow and what is discharge and what is continuity equation. For that one video already I have done. So that is nothing but rate of flow is Q. So we know that Q is the discharge of the fluid flow, and this also how to calculate this is, we know that AB, which is known as continuity equation, A1 V1, and the unit is, that is meter cube per second. Anyway, so this is the rate of flow of the liquid. Now this venturimeter, let me show you. Yeah, this is the venturimeter setup is there. Now it will be connected in a pipe. Okay, this device need to be connected with a pipe so that we can measure the flow, what is the rate of flow of the pipe. Okay, so for this you can see, suppose this is the inlet part is there, and here we need to consider two different sections. Okay, two different sections we need to consider, and this is one section and this is another one section. At these two sections we need to connect the pipe. Manometer need to be connected. The manometer can be connected in this side, in the top side, or also we can connect here in the bottom side also. Any of here we can connect the manometer. Okay, so in the manometer we can get the difference of the pressure. So when there will be flow will be there, we can get the difference in the water pressure, we can identify here. Okay, and this part is called convergent part. Okay, when the pipe is there, this is the pipe length is there, and this part is convergent part, and this part you can see throat part is there. Okay, that means when the liquid will be flows in that, the liquid is going to be converged here. Okay, and after that the throat part will have some the flow will be, the liquid will be flows with some velocity here, and after that again the pipe diverged here. So here what we can see, three different parts we can see here. One is convergent, throat, and divergent. Okay, so this venturimeter, as I told you, this is used for measuring the rate of flow. This is used for to measure the rate of flow. Okay, next, as I told you, three different parts are used here. One is converging part, this one converging part, and one is small throat is there, and diverging part is there. Okay, and this as I told you, this venturimeter is based on the Bernoulli's equation principle. Okay, so now let's find out the what is the expression, or what is the derivation, or what is the equation for the rate of flow through the venturimeter. So for that we need to consider a horizontal pipe which is flowing. Let's suppose some water is flowing in the horizontal pipe. Okay, and because we know that when there is a flow, liquid will be there, then only we can measure some rate of flow. Okay, so in the pipe, let connect this one, then we can find out some flow rate. So for that, section 1, as I told you, this is section 1 and section 2 to be considered. So we need to consider section 1, what is the diameter of that, what is the diameter at this particular position, and what is the, so D1 equal to diameter of the throat 1, or the diameter of the pipe at section 1. P1 is the pressure at section 1. Similarly, diameter P. Then next, velocity. What is the velocity of the liquid at the section 1? Okay, and similarly, diameter is given, means we can calculate the area A1. Okay, similarly, this is section 1 part. Section 2 also similar thing will be there. Similarly, D2, P2 and V2. diameter at the section 2, pressure at the section 2, and velocity at the section 2. And also we can find out, as diameter given, we can calculate also area of that. Okay, now what we'll do, this is common, okay, at both the section. Just I have taken this this parameters. Okay, now as per the Bernoulli's equation, we can write, we know that in the previous derivations already we have did, that is P1 by rho g plus V1 square by 2g plus Z1 equal to, we can write P2 by rho g plus V2 square by 2g plus Z2. Okay, so this is the Bernoulli's equation. Now, in this equation, Z1 and Z2 both will be same because the pipe is it is situated in the vertical position. If you consider a datum line here, so at this point, like you know, at the section of this one, what is the center line if you draw here? So how much distance is from here to here? The same distance will be from here to here. Okay, so that's why here we need to consider Z1 equal to Z2. Then what is the remaining part we can write here? P1 by rho g. And so what I'll do, I'll consider pressure one side and velocity one side. Okay, because these two are now not required. So what I'll write, P1 by rho g minus P2 by rho g equal to here V2 square by 2g minus V1 square by 2g. Okay, so this one also you can write P1 minus P2 by rho g also can be written. Okay, and this is, suppose, give some equation. First one give some equation 1 here, Bernoulli's equation, and this one we can give the equation 2 here. Okay, next what I can write here, if you see the P1 by P2, P1 minus P2 by rho g, if I write this one, P1 minus P2 by rho g, okay, this is the pressure difference. Okay, the pressure difference at the section 1 and section 2. But if you see P1 minus P2 by rho g, okay, this is the pressure head, the difference of pressure head. We know that P1 by rho g is the pressure head. Okay, and the difference of these two, P1 and P2, we can consider this is the difference of pressure head at section and section 2. So that one we can write H. That one can be mentioned as H. Now if you put the value of H here, so what we'll get here? H equal to, we can write V2 square by 2g minus V1 square by 2g. Okay, this is given equation, suppose 3. Okay, now let apply the continuity equation at section 1 and section 2, and we can write, as I told you, A1 V1 equal to A2 V2, and here we can write, either we can write V2 equal to some equation, or we can write V1 equal to A2 V2 by A1, or else we can write V2 equal to A1 V1 by A2. That also can be done. So now what we'll do, we'll put this value of V1 in the equation of 3. So then what we'll get here, implies H equal to, we can write V2 square by 2g minus, in the place of V1, just put this value of A2 V2 by A1 whole square divided by 2g. Okay, now let's solve this equation. What we'll get, H equal to, we can write, why I have done this one, because I want to convert all this velocity on single term, like you know, V2 is there means let me convert this one V2. If you want to convert this one V1, also you can convert it from this equation. Okay, so this is as per the continuity equation. Now what I can write, V2 square by 2g, and this one also you can write, okay, now A2 V2 square by A2 V2 by A1 whole square. Now if you just elaborate this one, what will get, V2 square by 2g, and we can write square bracket I've taken common, because here also we'll get the v2 square by 2g, I'll get it here. So from here and here, I have taken the common of v2 square by 2g. So here already v2 square by 2g gone out, means in the bracket we'll get only 1 minus, what we'll get here? a2 square by a1 square. a2 square by a1 square. Now the same thing again, what I'll do, I'll just write here one more term, v2 square by 2g, bracket start again 1, this one we need to write, this one, let solve this. So what I'll get here, in the place of 1 I can write a1 square minus, this is a2 square, and in the denominator it will be there a1 square. Now here bracket close. Okay, so here we got this equation. If you want to write in terms of velocity, then also what we need to do, suppose you want to write in the terms of velocity, I can write v2 square equal to, just take all this term to other side, in the left hand side. So what will get, 2gh, bracket start again we can write a1 square by a1 square minus a2 square, bracket close. Okay, now next what we can write, so h value we got it, this one, then again we converted this one in the v2 square term. So now what I'll write, I'll write v2 in the previously v2 square is there, now it is v2, so we'll get root over of 2gh, let's put the value of 2gh into a1 square divided by a1 square minus a2 square. This was the equation. So now solve this one. So what we'll get, let's take this term outside, so that we'll get, you know, a1 square, we'll take it out, a1, and suppose root over, if you want to keep it here, a1 square minus a2 square into root over of 2gh. Okay, so this is v2. Okay, now here, as I told you previously, discharge q, what I have considered here, this one, as per the continuity equation, q equal to a1 v1 a2 v2. Okay, so again we'll just put the value of q equal to a2 v2, because finally we need to find out the rate of flow, correct, and that is q. So now we got this value already, this is the formula a2 v2. So now a2 is there, now put the value of v2, so that is a2 a1. So I can write a1 a2 root over of a1 square minus a2 square root over of 2gh. Okay, so this is the equation I'm going to get from here, and this is nothing but q, this is nothing but q, and this one we can give equation 4. I hope up to 3 it is gone, next we can give it 4. Yeah, now this is our discharge equation for an ideal condition. Okay, and this is called actually the theoretical discharge. This is called theoretical discharge or the rate of flow of liquid. Okay, and if you want to calculate the actual discharge of that, so actual discharge will be less than the theoretical discharge. Always keep in mind the actual discharge will be less than the theoretical discharge. Okay, QTH. Now, so for that what we can write? We can write Q actual equal to, just we need to put one value of CD into this, multiply the CD into this equation. So that is nothing but this is theoretical. Yeah, or we can say QTH. So what we can get it here? CD equal to, CD is what? CD is actually coefficient of discharge. Okay, the coefficient of venturimeter, that its value is always less than 1. Correct. Now what I can write here? CD equal to, I can write Q actual by Q theoretical. Now here also I can write the equation Q actual equal to CD. Just you put this equation here, that's it. That is nothing but A1 A2 divided by root over of A1 square minus A2 square root over of 2GH. Okay, so this is the final equation of this discharge, actual discharge and theoretical discharge. So I hope you understand this venturimeter concept, and this is the small derivation of this venturimeter. If you are having any kind of query regarding this or doubt regarding this, you can give a comment on the comment box. I hope you understand. Thank you all.